is Lab 24, Example 3. We want to list all possible rational zeros, find all rational zeros, and factor f of x into a product of linear factors. We have f of x is equal to 6x to the fourth power minus 20x cubed minus 48x squared minus 12x plus 10. So first thing we're going to do is list all possible rational zeros. So we're going to do the PQ method. So we have P. P is going to be the last number here, 10. It's going to be the number without any x attached to it. And we're going to look at Q. Q is going to be the leading coefficient. It's going to be the number in front of the biggest x. The biggest x is x to the fourth, so it's going to be 6. And we're going to look at all the factors of P and all the factors of Q. So these are all going to be plus minus lists, since the negative factors are also included. So a factor of 10 is going to be 1 times 10 is 10, or negative 1 times negative 10 is 10. We also have 2 and 5. And if we look at factors of Q, this again is going to be a plus minus list. We have 1 and 6 for Q. We also have 2 and 3. And that's all the factors for Q. So we're going to look at all the factors of P and divide it by all the possible factors of Q. This is a plus minus list. So essentially it's all combinations. We're going to have 1 over 1, which is 1, 10 over 1, which is just 10, and 2 over 1, which is 2, and 5 over 1, which is 5. And then moving on, we're going to 1 over 6, 10 over 6, 2 over 6, 5 over 6, so on and so forth. And then we can do 1 over 2, 10 over 2, 2 over 2, and 5 over 2. And we can do 1 over 3, 10 over 3, 2 over 3, and 5 over 3. So it doesn't matter how you do it. It also doesn't matter if we have any repeats. For example, 2 over 2 is also 1. But these are all the possible rational zeros of our f of x. The next thing we want to do is find which of these zeros are actually zeros of our f of x. And we're going to do that by graphing. So, going to your graph, you're going to press y equals, and you're going to insert this function up here, 6x to the fourth, and so on, into your y1. And then you're going to press graph. So we see that we have 3 zeros. You can use your cursor to look at what those are. We have a 0 at x equals -1. Which again is a possible factor here. So you have a 0 at -1. If we go over here, we see 1 at around 0.3333 repeating, which is 1/3. So you have 1 at 1/3. And if we go all the way over here, we find 1 at 5. So that's all the zeros we have, the rational zeros we have for this function. We have x equals -1, 1/3, and 5. And so now that we know that, we can factor f of x into a product of linear factors. So this can be rewritten as f of x is equal. So the first thing we're going to put is our leading coefficient, which is going to be 6. So we're just going to put 6 here to multiply everything together. In our graph, one thing we should notice is that every single one of these zeros we pass through the x-axis except for this 0 right here. This 0 at -1 bounces. If it bounces off the x-axis like that without passing through it, that means it has even multiplicity. So because of that, for this first 0 right here, which we can write as x plus 1, it's actually going to have a 2 here because of this even multiplicity. We have this 0 in our function actually twice, at least. We know that has even multiplicity. It could be 4 or 6 times, but because we have a maximum of x to the 4th, and we have 3 zeros, and this has an even multiplicity, we know that this has to be a 2. So now that we know that, we can rewrite the rest of our zeros. This is going to be x minus 1/3 and x minus 5. And so if you actually counted the zeros, we have two zeros right here, 1, 2, 3, 4. That first term will come out perfectly.